Let's see what are odds. Suppose there are 8 games. Now what will be the probability of my team winning 5 games? It's pretty simple. The total number of ways it can happen, or number of events in favor, which is equal to 5, divided by the total number of events, that are 8. So it will be 5 by 8. Now on the other hand, odds are defined as count of something happening, means winning here, which is equal to 5, or you can say probability of winning, which is equal to 5 by 8, divided by count of something not happening, or you can say probability of losing, which is given by 3 by 8. So we will put these values and we'll get odds in favor as 5 by 3. Now if we put count of something not happening, which is equal to 3, or probability of losing, which is equal to 3 by 8, divided by count of something happening, which is equal to 5, or probability of winning, which is equal to 5 by 8, then the value that we will get, which is 3 by 5, will be called as odds against. Now these are the few terms that we will come across often. So I hope you have got the idea about it. Also, if you have noticed that here odds were expressed as counts as well as probability. But we will often see odds expressed in terms of probability. Now the next term that comes after this is log of odds. So we saw that odds in favor was 5 by 3 and odds against was 3 by 5. In short, we can say that odds in favor of my team will lie between 1 to infinity, and if odds are against my team, then it will be between 0 to 1. So these values cannot be compared because one value is lying from 1 to infinity and the other lying between 0 to 1. Hence, to address this problem, we take log. What log does is, it will make it symmetrical, ranging from minus infinity to plus infinity. It will be a normal distribution, and this is called log odds or log of the odds. Also, as we saw, odds can be calculated using count and probability. So when we use probability to calculate odds instead of counts, and then we take log of that probability, then log of odds is called as logit function. So that will be all from odds. Let's move on to the next concept. The next concept is confidence interval. Now we know that statistics is not an exact science. It's a guesswork. Now by guess, I don't mean it's a mere hunch, but it is a guess based on powerful calculations. So if it is a guess, we would want to know how good our guess is. Now how do we do it? We do it by calculating something called as statistical significance. So statistical significance are of two types, estimation and testing. Testing we will see later in the upcoming section. So we have a whole section for testing. Then the other one is estimation. Now estimation is nothing but what we have learned so far. It is basically using the information of sample to arrive at a conclusion about our population. In other words, using statistics such as sample mean, standard deviation, etc. to know about the population mean or standard deviation, etc. Now estimation, as you can see in the flowchart, is again of two types, the point estimate and the interval estimate. Now point estimate, as the name suggests, is an estimate at a particular point. But interval estimate is an estimate in the form of an interval within which true value lies. Hence the interval estimate is called as confidence interval. Now as I said, that confidence interval is computed from the statistic of the observed data that might contain the true value of an unknown population parameter. For example, a 95% confidence interval is a range of values that you can be 95% sure that it contains the true mean of the population. Now confidence interval is given by this formula. First is the sample statistic, such as mean, standard deviation, etc. of the sample, plus minus margin of error. Now margin of error is given as m into standard error. So m is a critical value here. You can use either t-score or z-score. And standard error is the standard error of the sample statistic. Means standard error of the mean or standard deviation, etc. for which we are calculating the confidence interval. Also, the center of our interval would be the point estimate. Basically, the sample statistic that is shown here is the point estimate. So here I have shown a normal distribution curve with a confidence interval of 95%. It is showing the value of x between 100 to 125. And it will be less than 100 only 2.5% times and greater than 125 only 2.5% times. So if we see the value of mu that is given here, it is the population mean and it is equal to 112. And the value of x is between 100 to 125. So we are 95% certain that our population mean will lie between this range. So this is what confidence interval tells us.